Number 5 on page 2.
Oh, you're not talking about the review questions? Did you see last night I put up the review 2.4 to 2.6? Annabelle?
I'm checking to see. I didn't see it last night, so.
Okay, so tell me the problem that you want me to do. You can stay unmuted. It makes it easier to have that conversation. It's okay to stay unmuted. What's the problem that you wanted me to do? Just tell me it.
Well, it wasn't on the review. It was on the other one.
That's okay. Tell me what it is.
It was number 5. Do you want me to, like, say the problem to you?
Yes, I do.
Okay. It's y equals 2, and then parentheses x minus 3 squared plus 8, and then it says the square root method.
This right here?
I can't see anything.
Oh. So this right here?
Yeah.
All right, so first off, you're supposed to make it equal to 0.
Well, yeah.
They call it the square root method. It's not the square root method. That's not what I call it. It's the process of how many different types of x's do you see?
1.
So what am I going to do since I only have one type?
The square root method.
But it's called isolation.
Oh, yeah, isolation. Sorry.
I'm going to get the x by itself. So the way that you do isolation is you work order of operations backwards because it's like I'm undoing stuff. I'm getting to this problem right here. So if I did this problem in forwards, I would do x minus 3, right?
Mm-hmm.
Then I would square it. Then I would times it by 2. And then I would add 8, right? And when I did all that, it would equal 0. That's what I'm telling you. Do you follow what I mean by that?
Yeah.
So what I'm doing is I'm undoing all that crap. So when I undo crap, I got to start where I ended, which means the last thing I did was add 8. So I'm going to minus 8. Which means if I had taken the x and I had minus the 3 squared it and times by 2, I would have got to 8. I'm saying, well, wait. I'm going to undo timesing by 2 by dividing by 2. I get negative 4 equals x minus 3 squared. Well, I would square it, so how do I undo that? You square root it. You square root it. This right here turns to I, and then plus or minus, because I put that in there, and the square root of 4 is 2. And then I add 3 to both sides, and I get 3 plus or minus 2i equals x. Did that make sense?
Yeah.
Noah.
Sorry, it's like writing.
You're fine. Noah, before you leave, you need to make sure I change your attendance.
Mr. Mark,
Yes.
could you scroll up a bit?
Farther?
Yeah, farther a bit. Okay, thank you.
Annabelle, do you have a question on that now?
No.
Okay.
Thank you.
Would you be able to do a question from the review last night?
Yeah.
It was number 12. I'll read out the question if you need me to.
So I'm going to get to that one towards the end of the class today. Is that okay if I wait? I'm going to start with number 1. I will probably get to, if I start going here quickly, I should probably get to number 12, and that'll probably be the last one I get to, 12 and 13.
Okay, thank you.
And then I will, so for what you guys are going to do is tomorrow in class, I will go over the review, and then you guys will test on Thursday.
I'll be absent on Thursday because I have a doctor's appointment. How would you want me to do the test?
Then the next time you come into class, you'll be here. You'll remind me, Mr. Martin, I was absent on Friday. You'll tell me you were absent. I'll open that test in, I do test in Performance Matters. So
Okay.
I'll open it up in Performance Matters for that period because you will only have the class period to finish it.
Okay, I appreciate that. Thank
Yeah, well, it'll be closed after that. But yeah, you'll take it Friday. And then whatever I do Friday, you'll just watch the video for it.
Okay, thank you.
Yep. All right, number 1. From the review that I put up online, I'm going to do a lot of talking. I'm not going to ask too many questions, so you're going to have to stop me if you don't understand. They asked me to factor this. Since they asked me to factor it, the first thing I'm always going to look for is a GCF. There is no greatest common factor between 16 and 25. So the second thing I look to is special cases. This is one of my special cases. This has a square root, this has a square root. However, this is not a subtraction sign because this is the algebra 2 difference of squares that I taught you. So it is still going to be a difference of squares, meaning the square root of this is here. The square root of this goes here, so it's 4x and a 5. 1 plus and 1 minus, that's all the same as difference of squares. However, because this is a plus sign, I have to put an I with the 5. And the reason that I have to do that is because if I just left it as a plus 5 and a negative 5, a positive 5 and a negative 5. Trey, you unmuted for a reason, bud? A positive 5 times a negative 5 would kick me to a negative 25 back there, and I need this 25 to be positive. So when I put the I there, what happens is I times I kicks to I squared. I know that by definition I squared is negative 1, and negative 1 times 25, negative 25 kicks me back to a positive 25. So when I have the plus sign here, I need to make sure I throw those I's in there.
So if it was negative, would you just not put the i's but do the same thing?
Yep. It would be
Okay.
a difference of squares problem that we had before. Exactly. You would just have a 4x and a 5, a 4x and a 5, and one would be plus and one minus. Exactly the same. No i's needed.
Okay, thank you.
Perfect. Questions on that other than that? All right, so the next thing, number 2, talked about 3 plus I minus 2 minus 2I. The big thing is this being a subtraction sign, I can't just drop my parentheses until I distribute that negative. When I do distribute the negative, I can drop my parentheses, and then all that does is change this from a positive 2 to a negative 2, a negative 2I to a positive 2I. It just changes all the signs. And then here, what I can do is I can do what's called the commutative property. Just make sure you move stuff around. I don't have to do this. Hopefully you can start doing this in your head, but you can move the crap around so that the like terms are near each other. This is a step I'm okay with you skipping as long as you go, I'm adding a 2, 3, and a negative 2 together, and that gets me to a positive 1. And a 1i plus 2 more i's is 3 i's. The thing we have to be careful of is I plus 2i is literally counting. You have 1 I here, you have 2 i's here, you have 3 i's total. Totally different than if I gave you the problem I times 2i. These two things are not the same, and this is what we mix up a lot of times in math class. And so this is 2i squared. You have to see the difference between these two. This is a plus sign, this is a multiplication. Here I have 1i plus 2i, that's a total of 3i. There's my final answer. Question on 2.
No, sir.
Number 3. This is the one where I need to recognize that I am multiplying these two. When I have bubbles right next to each other, or parentheses, this is saying a negative 7, or I, times a negative 7i. And so what I can really think of this as is 1i times a negative 7i. And this is really multiplying, this is really multiplying, so I can do 1 times the negative 7, and then I can multiply the i's together. It's a lot of dots. Put these as little x's, I guess. 1 times the negative 7 is negative 7. I times I is that I squared. Remember, add the exponents. I squared turns into a -1. -1 times -7 is a +7 is my final answer for number 3. Questions on number 3? Number 4. 4 minus I, 2 plus 5I. Here, I am going to distribute. Just like if I had x plus 3 and x minus 2, I would distribute all this stuff. I'm going to do that same thing to this one, just with i's. So I multiply 4 times 2. Did I write that down right? Yep. Okay, 4 times 2 is 8. 4 times a 5i. So what I do is I do this in couple steps. I think of this as a positive. So I go positive times a positive is a positive. 4 times 5 is 20. And then there's, so I just put I. Here I would do a negative times a positive is a negative. 1 times 2 is just 2, and I just stays there. And then finally I do a negative times a positive is a negative. 1 times 5 is 5. I times I is I squared. Whenever I have an I squared, I've told you to take that out and put a -1 in. -1 times -5 kicks this to a +5. So that takes care of all of that. Now combine like terms, and +8 and a +5 gives me +13. A +2i and a -2i give me a +18i. And there's my final answer. Questions on number 4?
That cleared that up for me. I appreciate that.
You're welcome. No worries. Do you have any questions? Or you sure you got it?
No, I understand now. I think I missed the step where you replace I squared with the -1.
Yeah, anytime. Yep. Anytime from now on we see I squared, we do not leave it as I squared.
Okay, thank you.
5. Oh, 5 is a great question. I don't think, some of you I think were not in this class. I don't remember if I taught you guys this one. Some of this might have been before we switched. I can't remember though. Maybe not. Right here, I have to realize that the problem is I'm not allowed to have I in the denominator. So what you were taught was, it's just like basic fractions. Whatever I do to the denominator, I have to do the top. So if I want to change the way this fraction looks, that's cool. If I times the bottom by 2, I can do that. I just have to times the top by 2 because really I'm timesing by the number 1. And when I do that, I create what's called an equivalent fraction. Well, just like that worked in like 3rd grade, because I think that's when you're taught that, it works with these ugly numbers. So whatever I multiply the bottom by, I just have to multiply the top by. It's just going to be a lot nastier. And what I want to multiply by is this thing's conjugate pair. Because if I do that, it's a trick to get rid of the I in the denominator. So notice I kept the 4 still negative, but this is going to become a +5i. Remember, whatever I do to the bottom, I do to the top. Now, I'm personally going to work on the denominator first because that's where the pain in the butt is. I know that these two, when I multiply these two, they are conjugate pairs to each other. What happens every time I multiply conjugate pairs together, also known as difference of squares? What happens to my middle term every single time?
Cancel out.
They cancel out.
So I don't even need to worry about my middle term is what I'm trying to tell you up here because I made that conjugate pair. I know their difference of squares. So I'm telling you, when I do this problem, I only multiply the -4 times the -4, which is 16. And I only multiply this times this. How come I can skip the middle? Because I know it's going to cancel out because I know their difference of squares. I made them that. So this is a -25i squared. Robert, anytime again I see an I squared, I'm going to change it to a -1. That's going to make this become a +25. And so on the bottom, I'm going to end up with a 41. On the top, I cannot skip that step because these are not difference of squares. That means I have to fully do it out, meaning -2 times -4 is a +8. -2 times a 5i is a -10i. This times this is a -4i. And this times this is a plus 5i squared. I can't skip the middle because it's not difference of squares. This right here turns to a -1, which makes this 5 turn to a -5. When I go to combine stuff up top, a 10 and a -5 can combine, and that makes 3. A -10i and a -4i can combine to make a -14i. Final answer. Does that make sense?
It's a little lengthy, but it makes sense. I follow.
Yes, it is definitely something that's a little bit of pain in the butt. Notice I deal with the bottom first. The reason I deal with the bottom first is because that's where the issue is. I'm trying to get rid of the I, so I made sure I got rid of the I. Then all I do is, really, do you see this is, if you look at this part, this top part, isn't that number 4? Like the process, isn't that the same thing as number 4? And this is really difference of squares, just multiplying them. So it's just a bunch of problems kind of coming together, if that makes sense, Robert.
I can see that, yeah.
So we're just building off of skills that we've already taught you.
Okay. Yeah.
And I wish I could tell you otherwise, but math is only going to get longer because you just keep building off the skills that you've already known. And so each one of these skills becomes a little part of a bigger problem until you start getting into like the concepts of calculus and that world problems of how to build this bridge and how far the spans can be apart, how much weight they can hold, and all those kind of real world problems.
All right, I understand.
So number 6, -2 minus 3i over 6i. What's the problem with this one? Again, oops, it's the I. So instead of multiplying by its conjugate pair, that I could do that, but that would just be a pain in the butt. The only problem is my I. How can I get rid of I? Well, if I had I squared, so how do I make I become I squared? I times it by I. If I multiply the bottom by I, I have to multiply the top by I to be fair. 6i times I just turns into 6i squared. I squared turns into a -1. And on the bottom, I have a -6, which is totally cool because there's no longer an I there. I then have to distribute this I because this has multiple things. So I got to go -2 times I, which is -2i. And then -3 times -3i times I is a -3i squared. Again, as soon as I see the I squared, I make it become -1. A -3 and a -1 kick to a +3. I don't like the way this is written. In fact, if I look for this answer, on the answer key or my multiple choice, it's not there. So I go, okay, Mr. Martin said something about the whole number has to be part, or the real number part has to go first. The imaginary part has to go second. So you could rewrite this as this. Notice the sign in front of it stayed with it. So the 3 had a positive, the 2 had the negative. So when I moved them, the 3 still has a positive, the 2 has a negative. You're still not going to see that answer. Let's go back to fraction work. Technically, how do I add these two fractions together? This becomes 1 plus 2 over 4, which is how you make it become 3/4. Well, hopefully you can see this fraction like this is identical to this fraction right here. And notice what you can do. What can I do with this 6? Because you don't see this on the answer, the test, the answers. It's not one of your A, B, C's, or D's. How can I apply this to this?
Have +3 over 6 plus -2i over 6, or -6.
And it's supposed to be a -6. That's my fault. And then this is a -2i over -6. And then this turns into a -1/2 when I reduce it. Divide by 2, this turns into a positive, because a negative, 1/3 I. And if you look, that's the answer you'll see on your answer choices. So please make sure you understand how to reduce and change. I told you Multiple choice isn't always easier because sometimes you have to get the answer they're looking for and not the answer that you have found. Number 7. Ooh. One minus 2i plus negative 2 minus I. Because this is a plus sign right here, I can actually just drop the parentheses and combine like terms. A 1 and a negative 2 turns into negative 1. A negative 2i and a negative 1i gives me negative 3i's. Questions on number 7?
So instead of adding like a -1 to a -2, you just do -2 minus 1?
Say that again.
Like the -2i and then the negative I. You would just do -2 minus 1 in the calculator instead of like plus negative.
I'm going to encourage you, Kelly, not to use a calculator for a special small
Just
number.
just in general. Like,
What I think of this is the way that I do addition and subtraction from now on. Is I think, are they the same or are they different? So what I mean by that is every time I have a positive and every time I have a negative, what are those going to do to each other?
sorry. Now, could you say that again?
Every time I have a positive and every time I have a negative, what do they do to each other?
They cancel each other out.
They cancel each other out. So if I have 5 and I have -2, I really think of this as not 5 minus 2. I think of this as 5 positives and 2 negatives. So legit in my head, I'm thinking I have 5 positives and 2 negatives. These 2 negatives cancel out these 2 positives, and I'm left with 3 positives.
All right.
So what I do is when I have negative 5x and I'm minusing 2x, I go, okay, that's 5 negatives. 2 more negatives mean I have negative 7x's. Because negatives make more negatives. They don't cancel each other out.
Yeah.
So
That
when I
makes
have
sense.
negative 2i's and I minus I, I go, I have negative 2 here. I have another one that gives me a negative 3i total.
All right.
So I think positive and negative more than I think adding and subtracting.
Thank you.
You're welcome. All right, 449x squared plus 36 equals 0. What are we supposed to recognize this is right away? Taylor, you asked me about this.
I didn't ask about that.
Yeah, you did earlier on a different question. What does it have, Taylor?
Oh. It would be 7, right?
A square. What are you saying? It has a square root. It's 7x. Be careful. Just it's 7x.
7x. Yeah. Okay.
This also has a square root, which is what?
6.
So what would be its factored version?
It would be. Would it be 7x?
Yep.
Plus 6i.
Perfect.
And then 7x minus 6i.
Perfect. Exactly. And yeah, I was referring to what we asked at the beginning.
Okay, I was so confused.
You're good. All right. Questions on that one? That was number 8. Number 9 says the square root of negative 60. Well, as soon as I see that negative, I'm going to put an I. I'm just putting it there because I don't want to forget it. And then I go 360, break it down 36 times 10, 5 times 2, 6 times 6, 3 times 2. This is called the prime factor tree. Every number has a prime factor tree except for primes. That means that I can rewrite the square root of 360 as really 2 to the 1, 2, 3 power times 3 squared times 5. If you multiplied all those together, you get 360. Now, there's an imaginary 2 here. How many times does 2 go into 3 without going over? 1. That means I get a 2 out. 1, 2 that's left over, though. How many times does 2 go into 2? It goes into it 1 time with none left over, so I scratch the 3 completely out. How many times does 2 go into 1? It doesn't. Sorry, 5. You have to stay inside. And the things that are left over inside are a 2 and a 5, and I multiply those together. It becomes a 10. I multiply the 2 times the 3. It becomes a 6. Square root of 10. But I can't forget this I. So my final answer is 6I. Square root of 10 is the same thing as that number up there. Those are equivalent numbers. This is just a simplified version of that. And this is what you're going to have to do anytime you see a square root from now on. You must simplify it. It's like seeing a fraction. You can't leave that in your answer. You've got to simplify that.
And do you have to put plus or minus at the beginning?
No, sir. Why not? What have I told you?
Because it's by itself.
Who put the square root sign there?
You.
No. This was already, when I say that, this was already part of the problem. Do you see a part of this original problem here?
No.
Do you see a square root at all?
No.
Do you now see a square root?
Yes.
You put that in there, then you must put the plus or minus. So if the square root is not part of the original problem and you put it into work backwards, that's when the plus or minus pops up. If the square root is already part of the original problem, there's no plus or minus needed.
Okay.
So if I ask you what's the square root of 100, what's your answer?
10.
If I say x squared equals 100.
10 or negative 10.
Do you see the difference between them? When you
Yes.
put the square root sign in to solve, that's when the plus or minus comes out. If this is already part of the original question, no plus or minus needed.
Okay.
Good question. Number 10. Whoops. That'd be funny. We'll take a recording of the recording. Wonder what it would do. So they tell you, being nice, to solve this by completing the square. That's a 10 in the middle, not a 16. Well, since they tell me that, the first thing I'm going to do is get rid of this 14 to the other side. And then I'm going to go, okay, x squared plus 10x. And then I'm going to leave a space, minus equals negative 14. I need some number that's going to make this a trinomial that's a perfect square. So the way I do that is I go, the square root of this is x. I would divide this by this times this is supposed to get me to 5x, so I know this is 5, but that's the square root of my missing number. So 25 was my missing number that would make this now trinomial a perfect square. I can add 25 to one side as long as I do it to the other. That's perfectly fair. The whole purpose of making this a perfect square is so I can actually factor it as a perfect square. When I do a negative 14 and 25, I get 11. This is going to factor into x, whatever the sign is, plus the square root of that, 5. Now I'm using the process, Annabelle, that we talked about at the beginning. I'm doing this kind of square root method, meaning since I have x right here all by itself, I can isolate it. So I can go, hey, square root this side, square root this side. Oris, you put the square root sign in there.
Yeah.
So we put a plus or minus. Then I minus 5, and I get x equals -5 plus or minus the square root of 11. There's my final answer for that one. Questions on number 10? Number 11. 3x squared equals 21. Since I only have one type of x, I can go ahead and do what we call isolation. Isolation means I'm going to get that x by itself. So I'm going to divide by 3. Divide by 3. X squared equals 7. Undo squaring by square rooting. Since I put it in there, plus or minus and square root of 7. Any questions on number 11? Number 12. Robert, this is the one you asked for?
Yeah, I believe so.
All right, Robert, what was the first thing I told you to do? What's the first way we're supposed to try to solve these? And by the way, this is different because now it's an equation, right? So I need to recognize that it's an equation, so now I can do these things that I've taught you. So what's the first?
Make it equal 0.
Not yet.
Oh,
Not yet.
GCF.
First thing I'm going to try is to isolate, meaning can I get x by itself?
Okay.
Can I?
No, there's 2 x's.
So, okay. Second thing we're going to try to do is factor. Okay. I'm going to try to factor this. And the reason I'm actually going to try to factor this is because that's a perfect square. I recognize that. So if I took the square root, it's not that big a deal. So I'm going to go, okay, is this a perfect square by itself? I'm not going to complete the square. I'm going to already ask, is this a perfect square already? The way to test that is the square root of this is x. Square root of this is 4. This times this is 4x doubled is 8x. I don't have to complete the square. It's already a perfect square. Do you get what I mean by that, Robert?
Yeah.
So then I can rewrite this as x minus 4 squared, and the quantity squared, equals 16. And now it turns into the problem we had just been doing, which I take the square root. X minus 4 equals plus or minus 4. And then that really just means x minus 4 equals 1 time it's positive 4. And there's also a x minus 4 equals a negative 4. And you solve both of those equations. You add 4, you get x equals 8 here. You add 4, you get x equals 0 here. And there's your 2 answers. Does that make sense?
That makes sense, yeah.
So the
I was
same thing.
confused. I think I just had like a mental block.
So first, don't give up on the first ones. We've been doing so many things kind of together. That's why I try to say this is the first way we try to attack the problem, and this is the next way. So again, I'm going to try to attack this by isolating. It's not going to work. I'm going to try to attack it by factoring, and what I do is I realize, hey, this has a square root, which is x. This has a square root, which is 9. And again, 9 times x is 9x doubled is 18x. That means I don't have to complete the square. Again, this is already a perfect square. So I can rewrite it as x plus 9 squared equals 25. And here we go again, undoing by square rooting. I get x plus 9 equals plus or minus 5. I make it 1 time where it's positive 5 and 1 time when it's negative 5. Minus my 9, I get x equals negative 4. Minus my 9, I get x equals negative 14.
Yeah, I got that one. I just didn't get 12 for some reason. I think it was just didn't click or something. But I understand that.
Good. Number 14. How do I find the missing value for completing the square? Well, I gave you easy ones on this test. The square root of it, or divide that by 2 is 8x. The square root of this is x. This times this has to get me here. Well, that means I'm missing an 8. 8 squared would be 64. My missing thing is 64. Please be careful on this, because there, if you notice what I keep doing is, let's say I had this. Notice, divide this by 2, it's 8x. Does everybody understand what I'm talking about? The square root of this is what?
2x.
So 2x times what would get me to 8x? 4. So what would be my missing value for this one actually is 16. Because this times this gets me to 8x. So I wasn't missing the full 8 this time, because it's not always just an x that's the square root. Sometimes it's a number. And so 2 times what got me to 8x. The 4, then I square the 4. 16 is my missing one to complete this square. Please be careful on that.
Would we ever run into a problem where the x can't be squared, like 3x or like 7x?
Then we wouldn't do completing the square.
Okay,
We
I
would use
thought
the quadratic formula for that one.
Okay, I thought so.
Okay.
I just make sure.
Yep.
All
All right,
right,
guys. We will finish up the rest of this tomorrow, and then your test is Thursday.
all right, have a good one.
And my
Have
odd
a good
class
day.
test is tomorrow. All right. Bye, guys.
Mr. Martin,
Yes.
on Portal, do we have to turn in the review today, or do you just want us to turn it in tomorrow when everything is done, or no?